Waalaikumsalam kak.
Waalaikumsalam doktor.
So now we have a last chapter, very last chapter, uh, which is graph algorithm or parallel algorithms. So in this chapter, actually, we have like 5-6 types of algorithms, and I just thinking that how I teach you in a simple way for these algorithms. So anyway, I will share letters YouTube videos. So I will teach you from that particular video as well because it's animated and it will be very, very useful and easy method. And you will get at least one question, one full question from these algorithms. Anyway, let me start graph algorithms or parallel algorithms. The topic overview is definitions and representation, minimum spanning tree, which is Prim's algorithm, and then single source shortest path, which is Dijkstra algorithm. K is silent, Dijkstra algorithm, all pairs shortest path, and algorithm of sparse graph. So we'll see today two algorithm only. So what is graph? Okay, so if I talk about there are two types of graph, directed or undirected. For example, undirected graph is a pair of V comma E, ordered pair, where V is a finite set of points called vertices. Okay, in graph we have two things, nodes and edges. Nodes and edges. So V is a finite set of points called vertices, and E is the finite set of edges. An edge, small e, belongs to capital E, is an unordered pair W comma V, where W comma V belongs to V, because V is a vertex. V is a vertex. Yeah, of course. The edge basically belongs to V because we have a node. If there is a node, definitely there is an edge. And in directed graph, the edge is an ordered pair U comma V, and edge U comma V is incident from vertex U and is incident to vertex V. We'll see next the diagram of direct graph and indirect graph. So anyway, we have path from vertex U to vertex V to U is a sequence V0, V1, V2 up to Vk of vertices, and where V0, V2, Vk is equal to U. What is U? We have an edge, and V1, V plus 1 belongs to capital E. What is capital E? Capital E is a edge. So the length of a path is defined as number of edges in the path. How many number of edges in the path? So, for example, this is number one example is a direct graph, and number two is a direct graph. So, can anybody tell me the difference between direct and indirect graph? Yes. See and tell me the very simple difference between direct graph and indirect graph. Yes, very easy. Hurry up, hurry up. Direct and indirect graph. Yes.
Directed graph is unilateral and undirected graph is bidirectional.
Very good, very good. And any other? Directed graph has direction. Okay. Directed graph has basically direction, but undirected graph has no direction. Undirected graph has no direction. You can see here, direct graph has direction. There is a arrow, and undirected graph there is no arrow, no direction. This is the main difference. Okay, one has direction and other has no direction. No direction means that, for example, an edge is mutual A to B means A is connected to B and B is connected to A. For example, just a Facebook, a friendship network where connection is mutual. A is connected to B and B is connected to A. This is the application actually. Use case is social media, undirect road networks, two-way streets, and computer network topologies. This is undirect graph. And what about direct graph, which has direction? An edge is ordered A to B means A goes to B, but not vice versa. B is not go to A, just because of direction. For example, a tutor follower network. For example, a tutor follower network where A follower B and B does not mean follow A. It doesn't mean that B follow A. A follow B. Okay, A follows B, but does not mean B follow A. This is an example of tutor. This graph is direct graph. It has direction. A goes to B, but not vice versa. Not B goes to A. For example, is use case, task scheduling, web page link, road maps in one-way streets. So these are the use cases. Faham?
Yes.
Yes.
So and that graph is a connected if every pair of vertices is connected by path. A forest is an acyclic graph and tree is connected acyclic graph. We see later a graph that has weights associated with each edge is called weighted graph. Weighted graph. A graph is an edge. Every edge there is a number. We call it weight. Okay, so graph can be represented by adjacency matrix or edge or vertex lists. Adjacency matrix has a value aij is equal to 1 if node I and j share an edge. Otherwise 0. In case of weighted graph, aij and wij, the weight of the edge. We will see later. The adjacency line representation, list representation of a graph, G, V, comma, E, vertex and edge, consists of an array adjacency of lists, which each list is a list of vertices adjacent to V. For a graph with n nodes, adjacency matrix take phi and square space adjacency list takes phi e space. How? Here. This is one is an undirect graph at its adjacency matrix. You can get this question in exam. You can see such a question, simple question. For example, we will give you an undirect graph. There is no arrow. And we ask about to write adjacency matrix representation. Okay. So how you will write this? Yes, anybody, just see the graph and the matrix. Yes, how they present 0, 1, 0, 0, 1. What does it mean?
It's that the first node is connected to the second node and not
Okay,
the other.
then
And then for the second node, it is connected to first node and the third and fifth node. And so
good.
on.
Then Pastu,
So the third node is connected to the second and the fifth node.
very good.
And
And
the
for the
fourth
next,
node is only connected to the fifth, and the fifth node is connected to the second, third, and fourth node.
yeah, fifth node is connected with fourth, second, and third, or second, third, fourth. Yes, very good, very good, very good. So this is very simple. So we can give you like complex undirected graph, many edges, many nodes. So you can draw, you can write the adjacency matrix in a simple way. Okay, any other body explain this? I want any other to explain this, please. Any other? As I forgot the name. Who explained this first? Yes. Who's explained this before, just now? I want his name.
Please,
Yes. Aflan.
yeah, I did as well.
Okay, Aflan. Okay, Aflan Hamani. Okay, so next, who will explain? Very simple. Undirected graph and its adjacency list. Here, list. Link list. We call it link list representation. Very simple. Yes. You have to draw like this. Yes, Aflan, explain. Very simple. One is connected to two. Okay, and you have to write the line, diagonal line that only one is interconnected with two. Okay, then Pastu, what about two? Two is connected with 1, 3, and 5. After 5, no connection. So you have to write, you have to draw diagonal line. What about 3? For node 3 is only directly connected with 2 and 5. After 5, no node. You have to draw a diagonal line. Then the node 4 is only connected with 5 and draw the diagonal line. And node 5 is directly connected with 2, 3, and 4. After 4, there is no other node, so you have to draw the diagonal line. Box with the, it means null, it means no other connection. Faham? Yes, guys.
Yes.
Okay, it's very simple. So this question, maybe you will see in the exam. Your test will be on week number 14. Okay. So your test will be on week number 14. Today is like week number 11. So we have only 3 weeks. 12, 13. If I said 2 weeks only. 14 will be your exam. And so in week number 14, no, you don't have any class. Okay, because Monday, we will finish everything. Thursday, we don't have any class. Okay. So week 14, Monday, we have a test. So Monday, week number 14, we have a test. Faham?
Yes, sir.
So we have a test on week number 14. So this is understood. Inshallah, on Monday we have a test 2, and test 2 will be on week 14. Week 14, the day will be Monday. Okay, in HPC lab or your respective lab. So this is one announcement. Second announcement is I already given you lab assignment, so you have to submit by next week, Monday, but online. No need to submit hard copy. Just you upload in Google Drive link, which is already provided by CR. So I'm requesting again to CR, please share the same link in the group, so they will upload their assignments. Will upload their assignments. The last but not least announcement is your project. So for the lab project will be individual. I will share the lab project by today, and you have to submit lab project with your hard copy on Monday. Monday means when you come for the final exam, when you come for the final test on Monday. So still we have time. It will consist of only 2 programs, okay? And the program is from multi-threading. So you have to expand that program in a good way, and you have to place your pages in folder, okay? So after this, I want to actually share some video lectures. So we have to see minimum span tree. Before this, I think I should share YouTube video. It will be easy for you, convenient for you. I will explain step by step. Hopefully you will be with me. Okay. So we'll start from the Prim's algorithm. We'll start from the Prim's algorithm. Okay. So what you have to do, you have to just keep the steps in your mind. I'm sharing the video in our WhatsApp group as well. Okay, let me share the video. I already shared in the group. Okay, I already shared the video in our respective WhatsApp group. Okay, so I already shared. Yes, all of you already got it. So let me share that video. Okay. Okay, this is basically Prim's algorithm. We have to find the minimum spanning tree. So we have to find minimum spanning tree. How we find minimum spanning tree, we'll see now. So for this, in this video, we will learn to find the minimum spanning tree, MST. So what is minimum spanning tree? A spanning tree of a graph is a tree that has all vertices of the graph connected by some edges. Okay, so a spanning tree of a tree in a graph that has all the vertices of the graph connected by some edges. This is the definition of spanning tree. So a graph can have one or more number of spanning tree. Overall, in one graph, we have one or more number of spanning trees. Okay. the part of graph basically, if I say. If the graph has n vertices, then the spanning tree will have n minus 1 edge, mean less than 1 vertex. If we have 4 vertices in a graph, how many edge? N minus 1, we have only 3 edge. We can represent with only 3 lines. We can represent 4 nodes with 3 lines. Line must be minus 1. Very simple. I will share many examples. You can see always when you draw the graph of 3 node, 1, 2, 3. If you have 3 node, you use only 2 line. You can use only 2 line. Understand? Okay, let me show you the minimum spanning tree is a spanning tree that has a minimum weight. That has a minimum weight than all other. Yes. So always we have n minus 1 edge. And the minimum tree is a spanning tree that has the minimum weight than all other spanning trees of a graph. We will see this, how we find the minimum tree in a graph, minimum spanning tree in a graph. So you have to see something. Okay. So before we start, I am requesting you to take some paper or pen and solve this problem with me. This will help you in understanding the algorithm in better way. Yes, please take out your pen and pencil, your stationery. Yes, please. Okay, should we proceed?
Yes.
Okay, so see now. Okay, let's start. Here's our graph. This is our graph basically. You will find the graph in your exam like this, any graph. So we'll see what is this. There's a loop in a graph. There's a loop in a graph, and there is a redundant link, duplicate link as well. So in this graph, we can find some loop, and we can find one multiple link also. So we'll see this. So this represent is edge. This is edge basically. And this represent the weight of edge. This number between 2 links B and D, the weight of B and D is 11. The weight of B and C is 4. The weight of D and C is 5. The weight of A and C is 10. And also 12 because 2 links. Okay, so this represent weight and this represent edge. Okay, and then we see. So first step, what you have to do in first step, you have to remove all loops. You have to remove all loops in a graph. So what is loop? Any edge that start and ends at the same vertex in a loop is a loop. How many loops? Yes. Anybody? How many loops in a graph? Based on definition, please tell me. Yes, please.
2 loop.
2. Okay, good. We have 2 loops in a graph. Okay. So based on this definition, we have 2 loops. Okay. So we have to remove loops. 1 loop, 2 loop. Okay. We already removed the loop. Step number 2, remove all parallel edges or duplicate edges between 2 vertex except the one with least weight. Except the one with least weight, having less weight number. So, where is the parallel edge in the graph? Yes? Where is the parallel edge? Yes.
B, A, and D, C.
No, only A and C. Only A and C. This is parallel edge. See? Parallel edge. A to C and A to C again. The weight is 10 and weight is 12. BC is not parallel. BC is different because BC is only one edge. There is no other edge for BC, only one edge. Here for AC we have two edge. A to C, the weight is 10. Again A to C, the weight is 12. Faham?
Faham.
Good. So, see, this is parallel edge. So we will keep the one with least weight, less number, weight number, which is 10. So see, you can see the note in this graph. Vertex A and C are connected by two parallel edges having weight 10 and 12 respectively. So we will remove 12 and keep 10. Faham?
Faham, sir.
See, we have two steps. Number one, remove the loops and then remove the parallel edges. Okay. After this, we have this graph. So now we're ready to find minimum spanning tree. So we have how many nodes? A, B, C, D, 4 nodes, and we have multiple edges. Okay. Okay, kindly draw this graph on a separate paper. We will be using in our calculation. I already shared this video with you. Later on, you can practice. So this is our graph. So first, what step number one was remove the loop. Two removes
The
parallel
parallel.
edges. And now step number 3 is to create table. So as our graph has 4 vertices, so our table will have 4 rows and 4 columns. This is a rule. Whenever we have how many we have vertices, so the rows and columns will be equal of that vertices. So 4 vertices mean 4 rows and 4 columns. So draw the table. So we already draw table A, B, C, D, A, B, C, D. So these are rows. The parallel are rows and verticals are column. So, and this representation cell CD, this one is CD. If I am here, it is BB. This is CA. This is AA. This is AB, AC, AD, like this. This is the representation at cell CD, where C is a row name and D is a column name. First, we call row name and then column name cell. So, how many cells in that table? 16 cells. We have 4 into 4, 4 cross 4, 16. Okay. So we have to draw a table. Table will be the rows column will be equal to the vertices. So rows and column name is same as the name of vertices. A, B, C, D, A, B, C, D, no issue. And similarly, this represent the cell DB, this arrow DB, D row and B column. So D is the row name and B is the column name. So very simple. We are in step number 3, drawing the table. Okay. So now put 0 in cell having same row and same column. So we will put 0 in first row, first column, because both have a same name. This is the rule, okay? So put 0 in cells having same row and same column. So where you put A, B, B, C, C, and D, D. So it will be diagonal V plus 0. Here, 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 diagonally we place 0. So we will now fill the other cells. We have to fill the other cells. So for the same name cell, we just place 0. We just write 0. A, B, B, C, C, and D, D. Faham? Yes. Good. And then find the edge that directly connects A vertex B, vertex A and B. We have to find the edge that directly connects vertex A and B. So how? In this case, we have an edge of weight 5 that has directly connected A and B. So we have to write the edge. So we write 5 in cell A, B, and BA because both are same A, B, and BA. So we write 5. So AB and BA, both cell we write same weight, 5. So understand? What we have done? We just write 0 in the same row and same column name, A, B, B, C, C, D, D. And then we have to start from A to B. So for AB, we will write the weight number, okay, in the table. Cell number AB and BA, same, because both will fill with the 5. This is first. And then find the edge that directly connect AC, AB, and then AC. For AC, we have 10. For AC, we have 10. So AC and CA. So we will write 10. In this case, we have edge of weight 10 that directly connect A and C. So very simple. So we write 10 in the cell AC and CA. Faham? And then we will find the edge that connects A to D. So in this case, A to D, we don't have an edge that directly connect A and D. So if this is the case, we will write infinity. We will write the sign of infinity in the cell AD and DA because we don't have direct connection. Understand? First, we have written just 0, having the same cell A, B, B, C, C, D, D. Then we start with the AB and BA same 5. And then AC will be 10, CA will be 10. And AD, we don't have any direct link. We write infinity to infinity in the place of AD and DA. Plus 2, we find the edge B and C. B and C. So B and C is 4. So BC and CB will be 4. So we write 4 in. Okay. So pastu BD 11. So BD DB 11. And then CD. For CD, we have 5. So we write 5 in CD and DC. So our table is completely failed. So now our next job is find MSD. Very simple. MSD, minimum spanning tree. First step, we removed loops. Second step, if exist, if no loop exists, no need. Then we remove parallel link, duplicate link. Third, we create a table based on the weights. How we create table? Table is consist of row and column. So how we know how many rows, how many column? Based on the nodes. We have A, B, C, D nodes. So we write 4 rows and 4 column, 4 by 4 table, 16 cells. And the column name and row name must be same as the nodes, A, B, C, D, A, B, C, D. And then we have to fill very simple way. Faham? Yes, any question up till now?
No, sir.
No, sir.
Okay, so I already shared this video, so you can see and watch this video again. Okay, the next step is to find the MST, minimum spanning tree. So see here, start from vertex A, find the smallest value in the arrow, row wise. Smallest value in the row A. So the smallest value will be, we will not calculate 0, okay? Yes. Smallest value, we will not consider 0 as it will correspond to the same vertex. So we will not consider 0, okay? So the smallest is 5. So smallest value in cell AB is 5. Five is the smallest unmarked value in row A. So we will mark the edge connected AB. AB will mark AB. So, yes, AB we highlight. You can see how they highlight. Yes. Okay. And then take AB and BSL. AB and BA cell. Because we already got the marked. Okay. Pastu, as we connected vertex A and B in the previous step, so we'll now find the smallest value in A row and B row. Now we will find both. We will see the both rows and find the smallest value. So what is the smallest value? In row A and B, 4, because 0 will not count. So we will not count, consider 0, and it will correspond the same vertex. Because 0 correspond the same vertex. So the weight will be 4. Smallest value is cell BC, which is 4. So what happens? Same thing. 4 is the smallest unmarked value in row A and B. So we will mark the edge connected vertex B and C. We will mark B and C. We mark B and C. Yes. So take BC and CB cell. BC and CB cell. Are you tick? So as vertex AB and BC were connected in previous steps, so we'll now find the smallest value in row A, row B, and row C. So we'll now see the smallest value in all three rows. Again, we'll not count 0. So we have the smallest value, which is 5. So we'll see all three rows, 0 will not count. And then we have a 5. 5 is the smallest value in cell CD. So we'll mark the edge connecting CD. Yes. So this is our MST, minimum span. We take CD and DC cell, and as we have marked all 4 vertices, so we'll stop now. Here we stop. Okay, we stop here, and finally we just take the highlighted edges. So a spanning tree with vertex, 4 vertices and 3 edges. So our minimum spanning tree is this one. This is our MST, minimum spanning tree. So weight of MST is 5 plus 4 plus 5, which is 14. We just count all the weights. 5, 4, 5. 5 plus 4 plus 5 is equal to. So this is all about MST, minimum span. We have to find minimum edges in a graph. We call it MST, minimum spanning tree. Yes. So what is the application of minimum spanning tree? Yes, please. So what is the advantage? What is the purpose? So in network design, it used to design cost-efficient network. Cost-efficient network like telecommunication network, it line cables between cities, computer networks interconnecting land, road, rail, or pipeline system. So in this design, in this network design, the goal is to connect all nodes with minimum total cost. Minimum total cost. With no cycle, with no loop. And we have different applications in image processing, computer vision, circuit design. At that, in circuit design, MST is used to reduce the total wire length when connecting multiple circuit components. Transportation and logistics, urban planning. So basically, MST is essential when the goal is to connect all elements of a system at lowest possible cost with no redundant connection. Faham? See, here we find this only, and we remove all other edges. This is minimum span tree. If I want to go to D, so we follow this path A, B, C, and D. Faham?
Faham, sir.
Good.
Paham,
So,
sir.
yes. Any question?
No questions, sir.
Okay, so very simple. I already shared this in the WhatsApp group. The the video link so you can repeat again about the Prince algorithm, so you can see normally Prince algorithm and other algorithms in the last question. But in paper you will have a complex, like you will see the more nodes, a graph with more nodes, like 7 nodes, 8 nodes, 10 nodes, like this. And sometimes we give you the table, and with the table you draw the graph. Okay, let me give you another example. One more example. Okay, this is example number 2. Algorithm number 2, we call it Kurzweil's algorithm. Kurzweil's algorithm. Let me share the Kurzweil algorithm. In our WhatsApp group. Okay, I already shared in our respective WhatsApp group the video number 2, or we can say the tutorial number 2. Okay. Okay, Kurzweil algorithm, the same thing, same rules, but bit different. Before start, I will request you to take some paper and pen, solve this problem. Okay, start. Here, this is the graph again. So here is our graph, and this represents the weight of the edge, this represents the edge, and this represents the vertex. A, B, C, D is the vertex. Okay. First, we have to remove the loops again. So any edge that start and end at the same vertex is called loop. Okay, this one, we have 2 loops in A and D. We already removed the loops from node A and node D, and then we remove all parallel edges. Okay, and we will keep the least value, which is 2. And now we are ready to find MST, but different algorithm. The first one was Prince, and this one is Kurzweil algorithm. So create the edge table. Here we write the edge table. An edge table will have the name of all edges along with their weights is in ascending order. Okay. So how many edge you have? You have 1, 2, 3, 4, 5 edge. Now we will draw the table based on the edge. First one was based on the nodes. Here based on the edge. Here we have 5 edge. 1, 2, 3, 4, 5. The 5 lines which are directly connected with the nodes. So edge and weight. So now look at the graph and fill the column 1 with the edge of minimum weight. Okay, In the edge, BC is the lowest weight, so we can select it. BC has one edge. BC is the lowest edge. We start from the lowest. So now look at the graph and fill the first column with the edge of minimum weight. So in all graph, we can see the whole graph. So we have 1. So 1 is BC. Edge BC and weight 1. And now AB. So we have AB and AC having minimum weight. So we'll select both. This is based on age and weight. In this case, we have 2 or more edges with same weight. Then we can write them in any order. A, B, and AC. Good. Now, first 2, we have 3. Okay, and then we have last but not least is 5. Okay. And see, very simple. Time to find the minimum spanning tree. Now we find the minimum spanning tree. There's a formula. Note, our graph has 4 vertices A, B, C, D, and our MST will have 3 edge. MST will always n minus 4 vertices. Mean if we have 4 vertices, MST will have 3 edge. If we have 5 vertices, MST will have 4 vertices. Okay, 4 edge, sorry. Okay. So how will we proceed? To find the minimum spanning tree, we will start for the smallest weight edge and keep selecting edges that does not form any circuit with previous selected edge. There is no connection. See, 1 is the smallest weight, so we select BC, BC. We selected BC. And then next 2 is the smallest weight edge AB and does not form a circuit. Will the previously selected edge and select it. So now we have AB. So we can take here AB. Okay, very simple. Thus AC, definitely it will cause a circuit because again loop. So we don't want loop. So we reject this AC. Okay, first 2 DC. So 3 is the smallest weight and edge DC does not form a circuit. So we just previously selected edge. So we select this DC here. Okay. So BD, if you write BD, so it will cause a loop. So since we got 3 edge, 1, 2, 3 edge, we got it. So we stop because we have forward test and we will go towards 3 edge, up to 3 edge. So our graph has 4 vertices, so MST will have 3 edge. So this is our required minimum spanning tree. Faham?
Faham, sir.
Okay, so
Okay.
I already shared both the videos. So I think for today, to algorithms are enough. So we have 3 or 4 more algorithms. So we will see in next 2 weeks. Okay. Any question?
No, sir.
Okay. So
Next week class online, sir. You say next 2 weeks.
sorry.
Uh next next week, Monday.
Yes.
Uh it will be face to face or online.
Face to
Just now
face. Face
sir
to face.
just now sir say see in next 2 weeks.
Next week it will be face to face, inshallah.
All right, sir.
Okay. Thank you very much.